Hi everyone, welcome back to my channel. Today we are going to discuss Laplace transforms. So what is the importance of Laplace transforms in control systems? That we are going to discuss. Importance of Laplace transforms. Importance of Laplace transforms. Listen here, to represent any control system, definitely we need mathematical models. In the mathematical models, we have so many differential equations takes place. So to calculate that complex differential equations, we need one tool. That tool is called as the Laplace transforms. In olden days, we have so many methods to calculate that mathematical models, such as Fourier series and Fourier transforms. And later on, we have Laplace transforms. So why we go for the Laplace transforms? So in case of Fourier series and Fourier transforms, if you want to find out the solution of differential equations, so you will take more time. But in the case of Laplace transforms, if you want to find out the solution of any complex differential equations, we need less time. That is the more advantage of Laplace transforms. The main advantages of Laplace transform is easy to calculate any complex differential equations. Okay, now how to calculate that Laplace transforms? So in the Laplace transforms, there is a scientist named Laplace. He was invented that formula. That formula is f of Laplace transform of f of t is equal to f of s. The formula is here. F of s is equal to integral minus infinity to infinity f of t e power minus st dt. Okay, now here I can write here the main use of Laplace transform is to convert the differential equations into Laplace transform. That means we are going to convert the time domain to S domain. So the main use of Laplace transform is to convert the time domain function to Laplace, that is S domain function. That is the main use of Laplace transforms. So Laplace transforms are used to convert time domain to frequency domain. That is the main use of Laplace transforms. Okay, now I can write here any function which is having any function. Let us suppose I can take this is f of t. I can represent in the form of Laplace transform. That is, Laplace transform of f of t becomes f of s. Any function in t that should be converted into s domain. So f of t becomes s here. Okay, so here we can convert t domain to s domain. We are using one formula that was invented by scientist. That scientist name is Laplace. Okay, that's why we can call as Laplace transforms. That means we are transforming the equation function from t to s. Okay, the function the formula is f of t, that is f of s. F of s is equal to integration minus infinity to infinity f of t into e power minus st into dt. So f of t multiplied with e power minus st dt. So here f of t is a time domain. The function, any function which is in time domain, that should be converted into, that is, s domain. So e power minus st is some function in s that should be multiplied with f of t, so we can get the the function in S domain. Okay, where S is equal to here sigma plus j omega, where sigma is called as the damping factor, so which is used to find out the stability of the function. So we will discuss later about this sigma, and also this also omega is also frequency of the that system, control system. So we'll discuss the sigma and omega later. Okay, so this is a main formula to convert any time domain function to S domain function. So this is a very important formula to convert any time function into the S domain function. So f of S is equal to integration minus infinity to plus infinity f of t multiplied with e power minus st dt. So this is the formula. So now here f of t, this is a function which gives the relation between the input and output here. So my input is f of t, and input is we are giving the control system, because of we are giving the input to the control system that will give the output here. So the output should be in S domain, because of to calculate the response of the system, definitely we need to convert the function from t domain to S domain. Okay, are you getting the point or not? Yes. So f of S is equal, this is a function. Now I am going to calculate some standard input signals that I have to give the control system. First of all, we have to convert that standard input signal to S domain function. Now how to convert the term to S domain? By using this formula. Let us see. Yes, the first standard input signal is step input signal, that is step. So Laplace transform of inputs function or signal. Okay, now we are going to find out the Laplace transform of that unit function. Okay, so we know that the definition of unit step input, that is here u of t is the input that should be is equal to t equal to 1 when t greater than 0, and t is equal to 0 when t less than 0. Okay, now this is the definition of a step function. Okay, and also I can represent this function in the form of graph like that. This is my graph here. So on x-axis I will take time, on y-axis I can take u of t function. So according to the definition, when t greater than 0, so when t greater than 0 means here on x-axis, on positive real axis, I can take positive values 0, 1, 2, 3, 4 and up to infinity. Am I correct or not? According to the basics here. So if you want to represent any function, definitely we can take positive real axis and negative real axis, and positive y axis and negative y axis. Okay, so according to the function, according to the definition of u of t, t greater than 0. T greater than 0 means here, so this is called as t greater than 0 and this is called as a t less than 0. Okay, so t greater than 0, u of t always 1. Let us suppose I can take, this is the origin 0, 0 and this is a 1. Okay, when t greater than 0, this is t greater than 0, this is t greater than 0, u of t is 1. So u of t is always constant 1 here. There is no variation of u of t function, it's always constant up to infinity. Okay, now here t less than 0. T less than 0 means here that is left, on the left plane. So we have to take, that is t less than 0, that is t value is u of t is 0 value. Sorry, this is u of t is equal to 1 and u of t is equal to 0. Okay, so this is 0 values of 2 minus infinity. Okay, so this is the mathematical notation, this is the graphical notation. So both are same. Okay, now find out what is the Laplace transform of u of t function, that is the unit step function, according to that Laplace formula. Okay, so we know that here the Laplace formula is equal to f of s is equal to integration minus infinity to plus infinity, that is f of t into it is e power minus st and dt. So f of t multiplied with e power minus t dt. Okay, here f of t, here f of t is the input signal that is given to the control system. Then f of t here is u of t, that is a step function, unit step function. Okay, I can write like that here, Laplace transform of f of t, that is here in the place of f of t I can write u of t, Laplace transform of, that is f of t. Okay, so that should be is equal to, according to the formula, integration minus infinity to infinity f of t, that is u of t and e power minus t and dt. Okay, here listen here. So minus infinity to infinity, this is a minus infinity and 0. In between minus infinity to infinity, there is a 0 is there. So minus infinity to 0 and 0 to infinity. So I can split this integration into two parts because of the function. The u of t function is available between the 0 to plus infinity. So which is not available between the minus infinity to 0 value. That's why I can split into two parts here like this. So my integration minus infinity to 0 u of t and e power minus st dt plus and integration 0 to plus infinity u of t multiplied with e power minus st and dt. Okay, so you know that here. So within the interval, this interval minus infinity to 0, u of t is 0. So what about u of t value? 0. This value is 0, therefore 0 into something 0, this total value is 0 here. Then what about this function here? So 0 to infinity, u of t function is 1. Okay, u of t is equal to 1, then 1 into e power minus st into dt. So simple integration we can do here. So integration, this integration 0 to infinity, that is e power minus st and dt. You know, this is general integration here. We know that here integration of e power minus at dt formula in mathematics. That is integration of minus at becomes e power minus at by, that is minus a. This is the formula for e power, integration of e power minus st. In the place of a, here s is there. Just we can replace here. So that is integration, that is e power minus st by minus s over the integral 0 to infinity. So I can write minus 1 by s outside because here s is a constant. T is the only variable here. Okay now. So minus 1 by s e power minus st over the integral 0 to infinity. Therefore minus 1 by s I can substitute upper limit and after over limit. That is upper limit e power minus, in the place of t I can substitute infinity, e power minus s into infinity minus and e power minus s into 0. Okay, therefore 1 by s minus 1 by s, you know that here, so e power minus s into infinity. Okay, that is infinity, e power minus nothing but 0, and this is 0 and minus e power minus, so s into 0, e power minus 0 is 1. Yes, so minus to minus plus, it is 1 by s. Okay, so this is a Laplace transform of step field function. That is the Laplace transform of u of t becomes 1 by s. That is the main advantage. So in the coming classes, if you see the u of t, you need to calculate all these complex derivations, calculations. Just we can substitute here 1 by s in the place of Laplace transform of u of t, just substitute 1 by s. That is the advantage of Laplace transforms. Okay na? So this is a simple example to calculate the Laplace transform of any function. Okay na? So I will tell you now some important standard input signals, important Laplace transforms formulas. Okay na? See. Okay, so you know that here Laplace transform of u of t is here. So 1 by s. This has domain. So Laplace transform of the step function is equal to, that is 1 by s. And Laplace transform of, that is t, it is a ramp signal. Okay, we'll discuss in the coming classes what is ramp signal. All this we'll discuss in the coming classes. No problem. Okay. Yes, Laplace transform of ramp, that is the 1 by s square. Next, and Laplace transform of t power n, that is n factorial by s power n plus 1. Okay. Next, Laplace transform of e power minus at, that is 1 by s plus a, 1 over s plus a. And next is Laplace transform of, that is impulse function delta of t, the impulse input which is indicated by delta of t, delta of t. Okay, delta of t is equal to, that is always 1. Okay, and again Laplace transform of cos omega t, that is s by s square and omega square. And Laplace transform of sin omega t, that is omega by s square plus omega square. This is some basic formulas that we are going to use in the coming classes. So please remember these formulas, very important. So listen here, to find out the Laplace transform of any function, no need to take all these calculations here, just use the formula all this here. So no need to use all this formula, just formula, just you can substitute and you can calculate the solutions. Okay, thank you and thank you very much.